Are you ready for a new kind of computer to change everything? Well, hold on a second. The short answer is yes, quantum computers are going to change our lives. But it will probably not happen in the way you see in science fiction movies. You will not be buying a quantum-powered laptop to check your email or watch videos of cats. Instead, this change will start quietly, behind the scenes, solving some of the world's biggest and most complicated problems. It is a revolution that will creep into our lives through better medicines, smarter financial models, more efficient energy, all within the next decade or so. This topic matters to all of us, even if we never personally touch a quantum computer. Think about it. The medicines that keep us healthy, the materials used to build our cars and phones, security that protects our bank accounts, are all based on complex calculations. Today's computers are powerful, but they have limits. Quantum computers promise to smash through those limits. They offer a completely new way of processing information, opening doors to discoveries that are currently beyond our reach. This is not just about making faster computers. It is about building computers that can solve entirely new kinds of problems. The journey into the quantum world has already begun. Major tech companies and university laboratories around the globe are in a race to build bigger and more stable quantum machines. Every few months, we hear about a new breakthrough, a new milestone reached. This is not a distant, futuristic dream. It is a present-day scientific adventure. To understand why quantum computers are so special, we first need to look at the computer you are probably using right now. This is a classical computer. It works on a very simple and reliable principle. Everything it does, from displaying this text to playing a video, is broken down into a language of bits. A bit is like a light switch. It can either be off, represented by 0, or on, represented by 1. All the amazing things your laptop or phone can do are built from billions of these tiny switches flipping at incredible speeds. They are fantastic at following instructions one by one. Now, let's enter the weird and wonderful world of quantum mechanics. A quantum computer does not use bits. It uses something called a quantum bit, or qubit. A qubit is not just a simple on or off switch. Thanks to a principle called superposition, a qubit can be a 0, a 1, or both at the same time. Imagine a spinning coin. While it is in the air, it is neither heads nor tails. It is a blend of both possibilities. A qubit is like that spinning coin, holding multiple values at once. This ability to exist in many states simultaneously is the first source of its power. But wait, there is more. Qubits have another amazing property called entanglement. When two qubits are entangled, they become linked in a special way, no matter how far apart they are. If you measure one qubit and find out its state, you instantly know the state of the other one. Albert Einstein famously called this spooky action at a distance. This connection allows quantum computers to create complex computational spaces where the information processed grows exponentially with each added qubit. It is like having your computer's processors all working together in perfect, instantaneous harmony. This does not mean a quantum computer is better for every task. Your classical computer is still the champion for things like browsing the internet, writing documents, playing most video games. A quantum computer, on the other hand, is a specialized machine. It is designed to tackle problems where you need to explore a huge number of possibilities all at once. It is not about being faster in general. It is about being able to solve problems that are mathematically impossible for any classical computer to solve, even if it were the size of a planet. So, where will we see the first real-world benefits of this incredible technology? One of the most promising areas is chemistry and the development of new materials. Simulating how molecules behave is incredibly complex. The interactions follow quantum mechanics, making them extremely difficult for classical computers to model accurately. A quantum computer, however, speaks the same language as the molecules. It can create perfect digital twins of molecules, allowing scientists to test new drug compounds, design novel materials inside the computer. This could dramatically accelerate the discovery of life-saving medicines and lead to breakthroughs like better batteries and more efficient solar panels. Another huge area is optimization. Routes for deliveries, scheduling thousands of flights, arranging production lines, all require sifting through mind-boggling combinations. Quantum computers, with their ability to evaluate many possibilities at once, could find better solutions faster, saving billions and reducing energy use. Much of today's encryption relies on problems too hard for classical machines. A powerful, large-scale quantum computer could one day break some of these codes, sparking a global race for quantum-resistant cryptography. Financial markets are complex, pricing derivatives, managing portfolios, assessing risk. Quantum algorithms could boost accuracy, enabling better predictions and a more stable, efficient system. The early impacts will likely start within 5 to 15 years. It is a marathon in stages. Prototypes in labs now, steady qubit and stability gains, early quantum advantage on specific tasks. So, in the face of this coming transformation, what should you do? The most important thing is to stay curious and get informed. You do not need to be a quantum physicist to understand the basics. Understanding qubits, superposition, and entanglement will help you separate real potential from science fiction hype. Knowing what quantum computers are good for and what they are not is the first step to being prepared. If you are in business or tech, start exploring now. You do not need your own machine. Map hard problems, try cloud access quantum processors, and build teams with quantum expertise. Policymakers and security leaders must begin the transition to quantum-resistant cryptography today. It takes years to develop, standardize, and deploy across government and the internet. In conclusion, the quantum era is dawning. A gradual sunrise. These machines will first tackle huge scientific and industrial challenges, with benefits trickling down into daily life. They will not replace your PC, but will work alongside it as a powerful, specialized partner. So, stay engaged, keep learning, and ask questions. The future will be a hybrid one, blending the best of the classical and quantum worlds.